Today's lesson is 10.7, Theoretical and Experimental Probability. We're going to keep going with probability. This is our second lesson on it, and we're going to have this one and one more. And probabilities can be kind of fun because if you like to play games, or if you like statistics, these are things that you will use in your life. So the first definition I have is theoretical probability. And the definition of theoretical probability is what should happen based on a situation. So, for example, if you have 4 cards and it's hearts, diamonds, spades, I think it kind of looks like this, and then clubs. We'll pretend that's our club. So if I said, what's the probability of me picking a heart out of these 4 cards? We know that in theory, the probability of me picking a heart out of these 4 cards is 1 out of 4. That's in theory. What should happen before you do anything else? Another example I have is rolling a dice and getting a 1. What should happen? Well, if I have a dice and there's 6 sides on it, and there's a 1 on one of those sides, I know I should roll a 1, possibly 1 out of 6 times, or 1 out of 6. That's what should happen if I roll my dice. So theoretical is what should happen just by looking at the information that's given to you. Now, experimental is what actually happens in the experiment. So you can find experimental probability by actually running an experiment and thinking about what happens. So before we said that to get a 1, it was going to be 1 out of 6. In theory, if I'm going to roll a 1, it's going to be 1 out of 6. Now, let's say this person did an experiment, okay, and I rolled a 1 6 times out of 12 tries. My theoretical probability, or my experimental probability would be 6 out of 12. Or if I reduce it, 1/2. So in theory, this is what was supposed to happen, but after I ran my experiment, this is what happened. So that's the difference between the two, and I'm going to talk about this again. So the difference between theoretical and experimental. This is what should happen based on the information given. Okay? That's what should happen. Experimental is when you run an experiment and what occurred in that experiment. So many people, remember last year, we talked about these two things. And it was hard for you guys to know the difference between the two. So that's why I made sure I had a slide like this, is so we could actually see the difference side by side. So theoretical is what should happen based on what we're given. It's without doing any experiment. Experimental is what happens after my experiment. All right, so we're going to practice both of these things, okay? So the first type of problem that we see, it says the table shows the results of a survey that asked 200 teens what they'd be doing if they weren't online. So if I look over here at my table, this altogether equals 200 kids. It already told me that the survey was out of 200. And 50 kids watch TV, 52 listen to music, 54 do sports, and then so on and so forth. So this says, what's my probability of kids listening to music? So since this is a experiment, this would be technically the experimental probability. So my probability, so many listen to music, 52 listen to music out of the 200 kids that they asked this survey to. Now usually we try to reduce this, and I can tell this is reducible for sure by 2. So we're going to reduce it, and actually by 4, which is interesting. So it would be 13 out of 50. I know it can be done by 2 and then 2 again. So this is technically my probability for that. Then sometimes you're going to be asked another question, like a follow-up question based on what you got beforehand. So it says, predict how many will listen to music out of 450 students. Now I need you to think back to the days of setting up proportions, and you can use a proportion to solve this problem. So if you know 13 kids listen to music out of 50, and there's 450 total kids now, By setting up a proportion, you can figure out about how many kids will listen to music out of 450. So if you can remember correctly, you take 450 times 13, you divide by 50, and I got 117 students. So what they're going to have you do is they're going to have you make predictions based on the probability that was given to you or the probability that you came up with out of the problem. We'll do another one like this. So it says, here's my table again. And first it says, find the probability of the students that like to draw. So again, out of those 200 kids, 10 out of 200 like to draw. And I can reduce this really simply. I know I can reduce that to 1/20th. So I know 1 out of 20 kids like to draw. So then it says predict out of a survey of 900 how many will draw. So if I know 1 out of 20 will draw, if I have a total of 900 kids, this is going to be my x. I'm going to do my cross products, and I get 45. So I know if I have 900 kids, there's going to be approximately 45 kids who like to draw. All right, now I want you to try one by yourself, and I'll give it to you. So I want you to find the probability of the students who read, and then I want you to predict how many will read out of 900 kids. So first you have to solve this. Then you can use that to help you solve the second part. All right, so I know that 54 out of 200 will read. So I'm going to reduce that quick. And I get 27 over 100, just divisible by 2. Okay, so that's my probability. Then if I know 27 out of 100 will read, I'm going to make that equal to 900. This is the easy one because all you would have to do is take 27 times 9. And you should get 243 students. Make sure that's right. I think so. Yep, 243 kids. All right, so that's being able to use your probability to make a prediction. So now we're going to really talk about the difference between theoretical and experimental probability. So we're going to do two things. First, we're going to do the theoretical probability. Then we're actually going to run an experiment, and we're going to figure out in theory or in the experiment what happened. So we're going to talk about a dice, and it says in theory, what's the probability of getting an even number? I know that on my dice there's numbers 1 through 6, and even numbers are 2, 4, and 6. So I have 3 of them. So I have 3 out of 6 numbers are even, so half are even. So now I'm going to run an experiment. And it says roll a dice 10 times. What's the probability an even number was actually rolled? Well, if I know that half is in theory what should happen, if I'm going to roll my dice 10 times, in theory, I should get 5 even numbers when I roll. So I'm going to make just a little thing here because we're actually going to do this. So this is my evens, and we're going to do odds. Okay, so now this is me running an experiment. So I got a 2. And then, come on. Okay, 1's an odd. Takes me forever to roll it. Okay, so there's another even. Right, so there's an odd. There's an even. There's an odd. So look at right now, we're neck and neck. Got an even. An odd. Look at. So it's 8 times. I'm going to roll 2 more times. I got a 5. 1 more. I got an even. So in my experiment, it actually turned out to be in theory what it was. So it was 5 out of 10 and it was 1/2. Now, it might not always turn up like that. Sometimes you get way more odds, sometimes you get way more evens. But honestly, the more times that you do an experiment, like if I would roll my dice 100 times, or if I would roll my dice 1,000 times, the closer it will be to the theoretical probability, believe it or not. So in this case, it turned out to be the same, but it's not always going to be like that. So let's do another experiment here. So this says, in theory, I want to know my probability of getting a 2. So in theory, first of all, my probability of getting a 2 would be 1 out of 6 again, because I know that there's 1, 2 on here. So let's keep track. And I'm going to roll 10 times again. So 1/6, what is that in a percent? So 1/6, it's not a great percent. So I've got 16.6%. So my percentage should be around that, but sometimes it'll be a little off. But like I said, the more times we do an experiment, the closer it gets to theoretical. All right, so let's see. We're going to roll 10 times. Why isn't it rolling for me? There we go. So a 3. Four. A 1. Come on, why aren't you coming? 5. 5. I have no 2s yet. 6. So I have 1, 2, 3, 4, 5, 6. I've rolled 6 times. I need to do 4 more. 3. A 1. So 2, 4, 6, 7, 8. 2 more times. 4. Come on, 2. Oh, a 3. So 2 is the only one. So this time, out of 10, so I have 2, 4, 5, 6, 7, 8, 9, 10. In my experiment, I got 0 out of 10. Which probably is pretty close because 0 out of 10 is 0% and 1 out of 6 is 16.6%. So really, it's actually pretty close. But like I said, the more times you'd roll this dice, if you'd roll it 100 times, if you'd roll it 1,000 times, most likely our percentages would be very, very close to the same, or our fraction would be very, very close to the same. So if you have any questions, let me know. We're going to keep playing around with theoretical and probability in class a little bit. So I will see you next class period. Thanks for watching.